Now let's set up how to simulate a Petri net. So basically Petri net is being simulated through a course of firing a multiple transitions. Okay? And then the firing transition, the rectangular shape, is going to be done when a condition is met. And the condition is being specified by the mathematical notations of the system. How? You remember that we had W here, the requirement specifications on the arcs. That condition, if that condition is being met, a transition can be chosen, can be a candidate of the fire. Okay, can be fired. And after that, after selecting all feasible transitions, randomness will occur. Random selection will occur to choose a transition, which transition to fire, and that transition will be fired. Okay, it's a random. However, we can set some priority. Okay, so conditions are for a transition. So here, for the places of all incoming arcs contains more tokens than the number of required tokens on the arcs. That is being discussed here. So here, let's say that if this is a transition and this is a required the from places, the source place, and here it says 1, and means that there should be 1 token here to be fired so that it can be removed. Okay, and the places of all outgoing arcs have available stock space for the generate tokens from the arcs. So what does it tell? Means that if this transition will be fired, it will place 1 token here, like this, 1 token here. However, some places will be able to set a capacity. And if that place has already so many dots and cannot place this 1 token here, then it cannot be fired. This transition will not be fired. Okay? And so this capacity can be another conditions. Okay? And number of specified transitions will occur. If by the Petri net simulations, and we are going to utilize here pipe simulator for the Petri net. However, there are so many Petri net simulators out there. We are just selecting one, and these Petri net simulators have very similar formalism and graphical notations that we discuss it here. Okay, and this pipe, for example, our chosen simulator pipe will execute a multiple transition so that we can see how tokens progress on top of the Petri net places. So here, pipe 2 can set up the place like this, place name, and how many will be initially being placed, and its capacity. Okay, and we can set up the transition and transition name and transition rate. So this will determine the priority and the timing. Okay, transition timing, and here is priority and so forth. Okay, and the arc will be able to set up how many tokens will be needed. Now we understand the graphical notation of the Petri net and the mathematical notation of the Petri net, and we know how to simulate the Petri net. Now what we can do is that we have a big blank sheet to draw Petri net and how to draw it. And this, the agony of creating something new will ask us to look into what were the others doing. What's the typical way of designing a Petri net? So design patterns will be another next our interest. So there are some design design patterns of the PatriNet, and one thing very natural is the sequential executions. Okay. So here we have place 1, 2, 3 and transition 1, 2, and they are linked in this tandem way. Tandem means that in sequential, lined up means. Okay, and here you can see that T2 can be only fired after firing T1 because it doesn't have a token here. Token is being placed here. Okay, so it means that T2 will require T1 to be fired. So there is a sequence of way of working, like the assembly line. So here we have something to assemble at the place 1, and then T1 can be fired. So this token will be removed, and token will be placed here. And then T2 will be fired and token will be released and placed it here. Of course, this is showing just one way of representing a token, right? And we can have multiple 2 tokens and fired 1 token here, 1 token moving advance. And T2 fired 1 token here, 0 token, and 1 token here. So these places will have like many tokens if that is being under the limit capacity of that places. Okay, that is being the sequential execution. Like for example, a scenario of the tandem assembly line in the manufacturing scene. And there is a synchronization. Okay, let's say that we have 2 parts to be assembled together and make a one product. So the part 1 and part 2, and they need to arrive at the same time and be ready at the same time to be assembled together. And their assembly of T1 will remove each of these tokens and place 1 assembled output being placed here. That is being synchronization. Okay, the above assembly and the below assembly will be synchronized to execute this transition. Okay, that is being the synchronization design pattern. And finally, the merging. If the synchronized pattern occurs, then these tokens will be merged. As I told you earlier, being 1 token and 1 token, there are 2 tokens. However, these 2 tokens will be removed by the specification of these arcs going in transition, and going out from the transition arc will specify how many are being output through this merge. Okay, so that token can be merged and transition will be limited until it's being ready. So these are the typical patterns, design patterns of the PatriNet.